Okay, so these are some examples of some spiral review problems that could be on exam 4.2. We're going to start with factoring. Number 15 says completely factor 3x squared minus 30x plus 75. When you first start to factor, you always want to look for a GCF. So what can get divided out of 3x squared minus 30x and plus 75? Well, I see that in my first term I have a 3x squared. So I'm going to look at all of these. Can they all be divided by 3? And they can. So I'm going to start there. So I'm going to factor out my 3. So that will give me x squared minus 10x plus 25. Now let's go ahead and factor what's in parentheses. Now some of you might be able to go ahead and figure out what that is, but if you remember, we taught you using the box method. So let's go ahead and make our box just by what's in parentheses. Well, we have 3 terms here, but we have 4 spaces in our box. The first term is going to go in the first box. The last term is going to go in the last box, 25. And then that middle term, negative 10x, we got to split it into 2 numbers. So in order to figure out what those 2 numbers are to fill in our remaining 2 boxes, we're going to go ahead and make a table. So how we make the table is we say the first term times the third term. That's what the numbers have to multiply to give us. So we need to pick 2 numbers that will multiply to give you 25x squared, but add to give you a negative 10x. So most of you can already pick what it's going to be. That's going to be negative 5x times negative 5x. And yes, that will add to give us negative 10x. So let's put that in here. So this is going to be negative 5x, negative 5x. Now go ahead and factor out of the box, and let's see what our factors are. So go ahead and pause the video and do that, and then restart it when you're ready. Okay, so hopefully you got the factors x minus 5 and x minus 5. So when we rewrite our factors, we need to also include the GCF that we took out in the beginning, and then go ahead and just write your factors x minus 5 times x minus 5. And so we have completely factored that polynomial. In the next problem, we're going to tell how many zeros the graphs have, what the sign is of the leading coefficient, and what's the degree of the polynomial. If you look at how many zeros it has, remember zeros, another word for zeros are x-intercepts. So if you look at the first graph, we have an x-intercept here, we have an x-intercept here, and an x-intercept here. So for part A, it has 3 zeros. Part B, what's the sign of the leading coefficient? That's all based on what the end behavior of the graph is, and on the end it's going up, so that means that the leading coefficient is positive. Part C, what's the degree of the polynomial? Well, the degree, it's going opposite directions on the left side and the right side. And you can see how many turns it has. It has 2 turns. So the number of turns is the degree minus 1. So if it has 2 turns, then that means the degree is 3. Okay, looking at the next graph, how many zeros does it have? It has a 0 here and a 0 here. So that means it has 2 zeros. For part B, what is the end behavior doing? It's going up, so that means the leading coefficient is positive. And for part C, how many turns? It has 2 turns, and it is going in opposite directions. That means the degree is 3. If you're looking at the third graph, part A, how many zeros does it have? Well, it doesn't cross the x-axis at all, and so that means that it has no real solutions. This is an example of a graph that has imaginary solutions or complex solutions. What's the sign of the leading coefficient? Well, again, the end behavior is going up, so that means that the LC is positive. And for part C, what's the degree of the polynomial? Well, we can tell that this is a quadratic. Quadratic has a degree of 2. Okay, let's move on to part number 17. Find the roots of 2x squared plus x minus 15. Well, I would do this on my calculator because it's asking for the roots, and we know that another name for roots is x-intercepts. So let's put this in on our calculator. Put it into y equals, and then let's graph it, and let's see if we can see where it crosses the x-axis. So if you've got your calculator with you, go ahead and type that in, press pause, and let's see if you can get it right. Okay, after you type this into your calculator, you'll see that the x-intercepts, or the roots, are at -3 and 2.5. Okay, so number 18, what are the zeros? So again, we're looking for zeros. Another name for zeros are the x-intercepts. So I hope that you're understanding by now that if it's asking for roots, zeros, solutions, you can always plug it into your calculator into y equals. You can graph it and look for the x-intercepts. After we graph this on our graphing calculator, you're going to see that it crosses at only one point, and that's where x is equal to 1, and that is the 0 of this polynomial. Okay, so in the next problem it says what are the factors? So let's review how to factor. If you'll look at this polynomial that it's wanting us to factor, you see that it has 4 terms. Well, we learned factoring using the box method, so let me go ahead and draw the box over here. In the box we have 4 spaces, and so it makes it real easy when you have 4 terms. The first term is going to go here. The second term is going to go in the next box, -6x squared. The third term is going to go into the third box, and the last term is going to go into the last box. When we were factoring trinomials, we didn't have that 4th term. We didn't have 2 middle terms, and so that's when we had to make the tree where it had to multiply to give you one number but add to get the other. Since we have 4 terms here, it's real easy to factor. So now let's divide out the column. In the first column, I can take out an x. In the second column, I'm going to take out the sign, negative, and I can divide out a 6. In the top row, I can take out an x squared. And in the bottom row, I'm going to take out this sign minus, and there's no common factor, but you remember it always has a common factor of 1, so we're going to take out a -1. Okay, so here are my factors. X squared minus 1 and x minus 6. But x squared minus 1 is a difference of squares. We know that because we can take the square root of x squared and we can take the square root of 1. So when you factor a difference of squares, you put it in 2 parentheses. You take the square root of x squared, which is x, and that goes in the first position. The square root of 1 goes in the second position, and you always separate it with 1 plus and 1 minus. And that way when you multiply it back together, those middle terms are going to cancel out. So let's go ahead and bring down our x minus 6, and now it's factored as far as it can go because these are linear binomials. Okay, last but not least, we've got number 20. It says given the function f of x equals 5 over x plus b plus c, which direction will the graph be translated when b decreases? Well, b is down here with my x value. As b decreases, that means when b is getting small. So let's think of our when b is equal to a negative number. If b is equal to a negative number, that means I'm going to have x minus b, and so that means that it is moving the graph to the right. Because remember, when it's inside with the x, it's moving left or right. It always goes opposite of common sense. So if b is increasing, that means that b is getting large. So let's think of our positive numbers. So when b is a positive number, it's going to be moving to the left. Okay, well let's look at c. c is over here at the end. When c decreases, so let's think of c as a negative number. When c is a negative number, that means I have a minus c, and that means that the graph is moving down. So if you'll remember, when it's added on to the end, plus or minus, it's either moving up or down. And it goes just like what you think it would do. When c increases, that means when c is a positive number, it's going to get bigger, so it's going to have a plus c, which means it is moving up. Now remember on these, if you ever are wondering what actually happens to it, just put in some numbers for b and c and graph them on your calculator, and let's compare them. If you're wanting to know what happens when b decreases, then put in a number where b is large and then a number when b is small, and compare the two. And that's the best way to do these problems. Okay, I hope you studied well for the test, and that you're going to do well. Come to class ready to go. Have a good evening.